Today we're looking at the graphing of the equation of a tangent. So the question that we have, the equation of a parabola is y equals to 5x minus 3x squared plus 8. We have two sections to this. The first one is what is the gradient of the parabola at x equals 2? And we also have what is the equation of the tangent to the parabola at x equals 2. So a couple of things that we may need to remember here. The first one, the derivative fx is the gradient of the tangent to y equals fx at each point of the curve. What that means is if we find the derivative of the function, then substitute our x value into that derivative, that will tell us what the gradient is. And you'll see how I apply that in a moment. The second thing that we need to know for the tangent of the parabola at x equals 2 is to understand what the tangent is. So a tangent is a straight line or plane that touches a curved surface at a point, but if extended, does not cross it at that point. So what you're looking at are these kinds of images here, where the black line is the tangent and it's touching the curve. Let's approach the question. What is the gradient of the parabola at x equals 2? So the first thing we need to do is we need to find the derivative of the function. In this case, the derivative will give us 5 minus 6x. Now that we have that derivative, we want the gradient at the point x equals 2. So that's what we're going to do. We're going to find the derivative value at x equals 2, which will give us 5 take away 12, or negative 7. So our answer, the gradient of the tangent at x equals 2 is negative 7. And we use our standard representation of that m there for the gradient. The second part of this question, we're asked what is the equation of the tangent to the parabola at x is equal to 2. So we're wanting to find the equation of a straight line, and we're going to have our final answer in the standard form of ax plus by plus c is equal to 0, where the coefficient of x, a, is positive. At the moment, the only information we have in regards to our tangent is the gradient. So we need to find or establish a second piece of information so that we can find the equation for the straight line. So what I'm going to do here, I'm going to find the value of y at x is equal to 2. So I'm going to take my function of y equals 5x minus 3x squared plus 8, and I'm going to substitute in the value 2, which will give me y is equal to 6. So the information that we know so far is that the tangent passes through the point 2, 6 and has a gradient of negative 7. What this allows us to do, we have the point and the gradient. So we are going to write the point gradient formula of y minus y1 is equal to m outside of x minus x1, where y1 and x1 come from the point and the gradient is, well, it's the gradient. I'm going to substitute each of those values in and simplify by expanding the brackets. What we now need to do is change this into standard form. So we want to have a positive coefficient of x. So in order to do that, I'm going to add 7x to both sides. This will give me 7x plus y take away 6 is equal to 14. Now again, I want standard form to equal to 0. So subtracting 14 from both sides will give me 7x minus y minus 20 is equal to 0. So our answer is the equation of the tangent is 7x minus y minus 20 is equal to 0. Now just to show you what that looks like, this is a graph of our original equation and its tangent. So you can see how the tangent touches the curve at one point only and it doesn't cross over. I hope this video has been helpful.